Hi guys, today we're going to be starting on a new mini unit called 6 Solutions. So at the back of unit packet 4, we're going to be jumping into the 80s. So if you don't have that out, take a second, please grab that out. I'll be going through the first half of this sheet with this PowerPoint, and then about halfway through we'll switch gears. I'll flip over to a smartboard and we'll go through the back half with a smartboard. So at the top of your sheet it mentions that there are 6 solutions around the room. We are not going to start the actual labs until next week, Monday, but we're going to talk about it, we're going to introduce it, and then hopefully by the time Monday and next week Wednesday roll around when we do the second part of the lab, you'll be ready to go and it'll make some sense. So, of these 6 solutions as a part of this lab, they are all going to be ionic. Okay? So what that means is that it contains a positive ion, and in the parentheses there, it's a cation, and a negative ion, which is called an anion. Okay, so when a solid ionic compound is dissolved in water, the ions dissociate. In other words, they break apart, disconnect, or they separate. Okay, so we're literally going to be taking different compounds, mix them with water, and when they're mixed with water, they break apart into 2 ions. Okay, so the most common example of this would be like table salt. You take sodium chloride. Okay, you put some table salt in a glass of water, you mix it up, and the sodium chloride solid is going to break apart into its 2 ions, and then after it breaks apart we get this little symbol behind those ions, which means aqueous. So whenever you see this little AQ, that stands for aqueous. And what that really means is you've got some solid dissolved in water. Okay, so aqueous, again, it's a solution. Okay, the solute is the ionic piece, whatever that may be. Okay, and the solvent's going to be water. So if you ever see little AQ, which we're going to see a whole bunch of, and we saw some of that last unit as well, that stands for aqueous, and it means that we've got something dissolved in water. So here's an example of that. Again, here's your table salt. It's like a little grain of salt. You put it in water, and then all these little Mickey Mouse looking water molecules kind of rip it apart into its 2 ions. Here's a negative chloride ion from the salt. Here's a positive sodium ion from the salt. And this is actually what's kind of happening when an ionic compound dissolves. These little ions break off into pieces, and the water molecules kind of surround them. Okay, so for the first part of the lab, we're going to work on writing dissociation reactions. We've done this before once, I believe, last unit, but we need to revisit it to make sure that we can actually do this. So a dissociation reaction is simply going to be the solid, okay, these 6 solids like that we have up here, on the left as a reactant. And then on the right, the product side, we're just going to break it apart into its 2 ions. And they're going to be aqueous, because at that point, they'll be dissolved in our water. Okay? The second part of this experiment, or this question, is going to be that we're going to write a statement about what happened. You'll see what I mean in the first example. So, in the first example, the one we gave you on your sheet, okay, we've got the solid lead 2 nitrate over here. We dissociate it, we break it apart into its ions. We have a lead 2 plus ion, and a nitrate 1 minus ion, or 2 of those nitrate 1 minus ions. So the statement here is going to be lead 2 nitrate dissociated into lead 2 ions and nitrate ions. Okay, so why don't you go ahead and try the next one? Okay, the next one is going to be this molecule right here. I'll let you name that thing on your own, but pause the video, give it a shot, and then after a couple minutes come on back and I'll show you the answer and talk about it. Okay, so if you did this correctly, you should have dissociated your silver nitrate into silver ions and nitrate ions, and then the statement here is going to be something like this: silver nitrate dissociated into silver ions and nitrate ions. Okay, so again, make sure that you realize that we've got some sort of solid, we put it in water, it dissolves, and then we get these aqueous ions as products. Again, try the next one. Feel free to pause the video for a couple minutes, give it a shot, and then come back and see how you did. Okay, so for this one, again, we dissociate it. We're going to get 2 sodium 1 plus ions and 1 carbonate 2 minus ion. Okay, and our statement's going to read something like this: sodium carbonate dissociated into sodium ions and carbonate ions. Okay, so at this point you kind of get the pattern. All right, why don't you pause the video again and do the remainder of what we have left on the front of the sheet. So finish up all these dissociation reactions, pause the video, and then come back and I'll show you all these answers, and I'll kind of go through them pretty quickly. And then we'll jump into the bottom part of the front sheet, and then in a little bit we'll transition into the smartboard and the back side of the sheet. Okay, for the next one, we have Ki, potassium iodide. That's going to dissociate into a potassium ion and an iodide ion. So the substance is going to be potassium iodide, dissociates into potassium ions and iodide ions. Okay. The next one after that is HCl gas. Okay, it dissociates into a hydrogen ion and a chloride ion, and again, the sentence would read something like this: hydrogen monochloride dissociated into hydrogen ions and chloride ions. Last but not least, NaCl. We dissociate it into its ions, and again, the sentence or statement: sodium chloride dissociated into sodium ions and chloride ions. Okay, so as a part of this lab, what we're going to need to do is we're going to need to be able to recognize if a reaction actually occurs. Alright, so you've had hopefully a little experience with this in either Science 9 or Science 10 or a previous science class, but there's a couple of key observations that we can make when looking for a chemical reaction. Okay, so why don't you take a minute to yourself, think about what sort of observations you could make to recognize whether or not a chemical reaction occurs, and then why don't you take another minute after that and talk to the people around you, okay, and kind of compare your answers. So we've got 4 boxes at the bottom. The goal here is hopefully that you can figure out or think about 4 different things or 4 different observations that we can make to see if an actual chemical reaction has happened. So go ahead and pause the video, take a minute for yourself, and then take a minute to talk to each other. Okay, so the things we can look for. Bubbles. If you see bubbles forming, that's an observation that would tell us that maybe a chemical reaction has occurred. A color change. Okay, that's another one. Precipitation forms, and that's really what we're going to be looking for in this lab, by the way. The vast majority of the reactions that we see will be what are called precipitate reactions. Okay, so we'll talk about precipitates just a little bit more on the back side of the sheet, and I'll get there in just a second. And then the last one would be like a temperature change. Okay, so if the little solution gets really, really warm, or even the opposite of that, which is a little more rare, but you can also sense a chemical reaction if something gets really, really cold after you mix it together too. But we won't have an example of that in our lab, but that is a possibility. Okay, so these 2 video links are here if you'd like to check them out. You're more than welcome to. They're rather boring if I'm being honest with you. They're just showing what a precipitation reaction looks like. So I'm going to skip over those and just jump into the smartboard for the back side of the sheet. So let's go to the back. Okay, so on the back side, it's going to get closer to kind of the actual lab that we're going to be working with. And this is going to talk about precipitation reactions here to start with us. So when we mix 2 solutions, what we're really doing is we're mixing 4 different ions. Okay, so from those dissociation reactions on the front, if we put something in water, okay, an ionic compound in water, it breaks apart into a positive cation and a negative anion. Okay, so really, if we mix 2 solutions together, we've got 2 positive things and 2 negative things that get mixed. Okay, so what that's going to do then is we can kind of think about that and figure out, okay, well, which of those ions will actually react with one another. Okay, so when we do this, we're primarily going to be looking at whether or not we get a solid. In other words, that's a precipitate. All right. So a precipitation reaction, like I kind of referenced earlier just a little bit, is when you mix 2 solutions, okay, and after you mix them, a solid actually falls out or forms from that solution, okay, and that solid is called the precipitate. Okay, so if a positive ion from one solution is insoluble, meaning not going to dissolve, when attached to the negative ion of another solution, then the mix of those 2 solutions will make an insoluble solid called a precipitate. That's really the bulk of what this lab's going to be, is we're going to be mixing unknown solutions together and observing whether or not a precipitate actually forms. Okay. So we have HCl and NaCl. This would be an example of 2 things that we could mix together. We'd have a solution of hydrochloric acid, a solution of sodium chloride, mix them together, and then we have a couple options of ions that we would be mixing. Okay, so HCl is going to break apart into H1 plus and Cl1 minus. Sodium chloride is going to break apart into Na1 plus and Cl1 minus. And then the question is with those ions that we have from these 2 dissociation reactions, can any of those ions come together and make a solid, or in other words, make a precipitate? And the answer in this case is actually no. So the H can only form, the positive H can only really form with a negative part, okay? And the positive H only has an option of forming with either a chloride here or a chloride here. And if it wasn't a precipitate the first time it mixed with chloride, like it did from this first reaction, it's not going to be a precipitate whether it mixes with this chloride or the other one. So no precipitate would form in this example. Okay? So we kind of mix and match. We swap partners, basically. The first dissociation has a positive piece. The second dissociation has a positive piece. The first one has a negative piece. The second one has a negative piece. So what we really do is we take the positive piece from one dissociation, we check it with the negative portion of the other dissociation, and see if that's going to actually make a precipitate. So what that brings us to is something called a solubility table. So there's a table that we can reference on the back of your periodic table that's going to help us determine whether things actually will make a solid or whether they will actually react or not. Okay? So flip over your periodic table. If you don't have that out, please grab that out. Let's flip that over. And we're going to check and see how to read that thing, because that's going to be a very, very big part of this lab. So this is the region you're looking for on the back of your periodic table. It looks kind of crazy and there's a whole lot going on, but we can hopefully have some examples here and reference this thing and figure out how to read it, how to use it, and how we can solve our problems in this lab. Okay, so at the bottom here, we've got a couple examples. The first one's done for you already. And the goal of this is we're mixing two solutions. Okay, in this first example, we're going to mix some sodium phosphate and some zinc sulfate. And the question is which of these combinations of positive cations and negative anions is going to give us a precipitate, a solid? So what we have to do is we have to look at the possible combinations. Again, we're going to kind of switch partners. Okay, so we're really going to look for a sodium and a sulfate in our chart, and we would look for a zinc phosphate in our chart. Okay, the best way to read this chart is actually from right to left, which is a little backwards from what we normally do, obviously. So hang with me, but let's look at sodium sulfate first. What we want to start with is the negative ion, the anion. So let's trace down, let's find sulfate. It's right here. Okay, then we trace left. What cation or positive ion is with it? Sulfate is going to be potentially mixed with the sodium. So let's find sodium. I don't see it. But we have this sentence or this statement in there that says including all others, or all others including, right? So if we don't see it, it must be in that all others piece of our solubility table. So sulfate mixed with something all other that's not included here. We trace further left and we see that that's soluble, meaning aqueous. That is not a precipitate. It's not going to make a solid. So sodium sulfate, the first combination that we checked, isn't going to work. Let's check the other one. Zinc phosphate. Same thing. We trace down the negative ions first. Phosphate's circled for us. Okay. Then we trace left. I don't see zinc anywhere, but again, we have this statement that says all others. So if we don't see it, the zinc must be a part of that all others. We trace further left across that line, and we see that it should make a precipitate. So in this first example, zinc phosphate, that combination is going to give us a precipitate. Now, when you make a new compound, we have to make sure these charges balance out, right? Like we did back in like one of the first units. Whenever we make a compound, your positive cations and your negative anions have to balance out so that the total charge of your molecule here is 0. Okay? So, for the next one, go ahead and pause the video. Take a look at the second example. Give it a shot. First, write out 2 dissociation reactions. And then combine your ions. Use your solubility table and see or determine which of these is actually going to make our precipitate. So pause the video now and come back in just a little bit. Okay, so in this next example, we're mixing some silver chlorate and some ammonium carbonate. And here are the 2 dissociation reactions you should have. Please check your work. Okay, and at that point, then we can try to make some pairs and see whether or not we're going to get a precipitate. So the first possible example we could get is silver carbonate. And we have to check our solubility table. We're going to find carbonate on the right-hand side first, way down here. We're going to trace left. I don't see silver anywhere. And if I keep tracing left under the all others, because that's where silver would be, we get a precipitate. So the silver carbonate is going to be our precipitate in this first example. But let's just check the other one just to make sure. If we look up the other one, which is ammonium chlorate, again, we want to start with the negative ion. I trace over on the right-hand side. Here's chlorate way up top. I go to the left. Everything with chlorate is going to be soluble. So ammonium chlorate is not going to make a solid precipitate. The answer here is going to be our silver carbonate. So the formula for that, again, we got to balance those charges. It's going to look like this, Ag2CO3. And the name is just silver carbonate. Silver only has one possible charge, so we don't need a Roman numeral as a part of that name. So go ahead and pause the video. Try the next one, please. Again, after a little bit of time, please come on back, and I'll give you the answer for the next one. Okay, in the next example, we have lead acetate mixing with potassium chromate. Again, we have to write out two dissociation reactions to show what possible ions we could use. So in this example, we're going to mix a potassium with an acetate ion and a lead 2 ion with a chromate ion. And we've got to look these up on our periodic table. So let's try the potassium acetate one first. I'm going to look acetate up. It's way up top. I trace to the left. Everything that I mix with acetate is going to be soluble. So this is not going to be our precipitate. That's not what we're looking for. The other example here is lead chromate. Let's find chromate way down at the bottom, the very bottom one. We trace left. We find lead 2 plus right here. So lead 2 plus with chromate is going to be a precipitate. That's our solid. So the formula for this is just going to be a nice 1-to-1 ratio because this is 2 plus, this is 2 minus. So there's our formula. And the name is lead 2 because lead does have more than one possible charge. We do have to include a Roman numeral, chromate. Pause the video one more time. There's one more problem. Give it a shot first, come on back, and then I'll show you the answer for the very last problem. Okay, in the last one, we're mixing magnesium chloride and potassium hydroxide. So magnesium chloride dissociates into magnesium ions and chloride ions. Potassium hydroxide dissociates into potassium ions and hydroxide ions. Again, we've got to pair these up, see which could possibly make our precipitate. Let's check this one first, the potassium and the chloride. I find my negative ion on the right-hand side. Here's chloride. I trace left. I look for potassium. I don't see it. It must be under the all others, which means that's soluble. So that is not our precipitate. Let's check the other one. I find hydroxide on the right-hand side. Here it is. I trace left. I look for magnesium. I do see magnesium this time, okay, which means it's going to make a precipitate. So magnesium hydroxide gives us our precipitate. That's the solid that we're looking for, and that's the one we're going to make. The formula here, again, we got to make sure that balanced formula is neutral. So we need 1 magnesium for every 2 hydroxides, and the name is just magnesium hydroxide. Alright guys, well I hope that was helpful. This lab, again, will start tomorrow, and then we'll jump back into it next week. We'll start it on Monday next week, and then we'll work on it Tuesday and Wednesday as well. So this was the intro sheet. I hope you understand what dissociation reactions are kind of about. I hope you understand how to use your precipitation table or your solubility table so we can find which of these various combinations is going to make a precipitate. And if you have any other questions or need any extra help, obviously come find myself or Mr. Scheidler anytime. More than happy to help you guys out.